This video covers our notes 11.1 over rules of exponents, day 1. So with our rules of exponents, we're asked to expand each expression or make it the longest and then most simplified version. So anytime you have an exponent, whatever your base is whatever, like in this case our base is t, is being raised to the exponent, and your exponent tells you how many times you raise or multiply that base times itself. So t is our base, and it is being raised to an exponent of 3, meaning it is t cubed, or t times t times t. T to the 4th is the same base of t, but this time times itself 4 times. Now, in all, when we count, we have 1, 2, 3, 4, 5, 6, 7 t's total being multiplied by itself. So t to the 3rd times t to the 4th is going to equal t to the 7th. Let's look at another one. Problem 2, we have 5s squared. So 5 times s times s. So it's s times itself 2 times. And we're multiplying it by 6, and then s times itself 6 times. So 1, 2, 3, 4, 5, 6. So to simplify this, we have 5 times 6, which is 30. And then we have s times itself 1, 2, 3, 4, 5, 6, 7, 8 times. Now a pattern you might be starting to see with our exponents, 3 plus 4 equals 7. On this side with our exponents, 2 plus 6 equals 8, which is the exponent we have. So on your formula chart, there is a property of exponents. The formula chart has a bunch of different sections. So this is in the second section, is the first one down. It says it's the product of powers. So what this is showing us is if we have the same base, we can add our exponents. Note that it doesn't say anything different about big numbers in front. Big normal numbers in front are not changing. The only rule that this applies to is our exponents. So for example, x squared times x cubed have the same base of x, so we are going to add the exponents. 2 plus 3 is 5. So anytime you see something with multiplication, your bases are the same and stay the same, and then you add your exponents. So for example 1, 2 is my base. Because it's the same base, I leave my base the same. Just like here we had x, x, so my base is x. We don't do 2, 2, and my base is 4. My base is 2. And then I add my exponents, 3 plus 5. So this will give me 2 to the 8th. Now, alternatively, you can put this whole thing in your calculator. When you plug it into the calculator, we have 2 cubed times 2 to the 5th. Note that I'm using this arrow down here underneath the clear button to get to my exponents. If you're using a newer calculator, it will put it up in the exponent for you and look just like what you have on your paper. And that answer is 2 to the 5th. We can also type in 2 raised to the 8th, but that's where the 256 comes from. So you can either simplify it by hand and put it into the calculator, or just put it into the calculator straight out. So, problem 4. Big numbers are normal numbers. No matter what rule you are using, your big numbers will be treated like normal. 2 times 3 is 6. Into the 5 times into the 4, these have the same base, so we will add them. 5 plus 4 is 9. For my answer, I just put it all back together. For problem 5, multiply the big numbers. 14 times 2 is 28. Now, I have x squared here. I do not have any more x squared, so my x squareds will stay the same. And then this is kind of like combining like terms. Y to the 4 plus 3 will give me y to the 7, so we have 28 from the big numbers. X squared stayed the same, and then y to the 7th. Keep in mind that each of those exponents goes specifically with that letter. The 2 goes with the x, the 7 goes with the y. You cannot do this and tell me you have 9 x's and y's total, because this is really saying x to the 1 and 9 y's. So that is not the same. So remember, you only put them together if they have the same base, the same letter. So on 6, we have 10, 3, and 2 all being multiplied for 60. We have x to the 1/2, and x squared. So I add 1 plus 1/2 plus 2. Put that into my calculator, and I get 3.5, which is really 7/2. And then on my y's, I have 9/2 plus 7/2 over here, which will give me 8. So my total answer is 60, x to the 7/2, y to the 8. For problem 7, they're asking us to find the area in square units of a rectangle that has a width and a length. So when we have an area, we have length, width. To find the area, we multiply length times width. So my area is going to be 4x 5y to the 1/3 times 2x squared y squared. So I multiply big numbers. 4 times 2 is 8. X to the 5 plus 2 is 7. Y to the 1/3 plus 2 is 7/3. Put all those answers back together for my final answer of 8x 7y 7/3. Now on the back, we're learning a new rule. So this one is not the same as the front. On the front, we were multiplying our problems, and we added our exponents. On the back, we're going to do something a little different. We're still going to start by expanding and reducing. So b to the 5th is b times itself 5 times. That is what the idea of an exponent is. On the bottom, b squared is b times b. Okay, just like 2 squared is 2 times 2, or 5 squared is 5 times 5. It's whatever the big number is times itself, however many times you have the little number. Now, anytime we have something we're dividing and we have something on the top and the bottom, they will cancel out. So in this case, I'm left with b times itself 3 times, which is just b cubed. Problem 9, we're going to do the same thing, but they're flipped. So b squared is on the top, b to the 5th is on the bottom. So for this rule, my b's cancel, and I have b times itself 3 times on the bottom. Okay, now this can also be written as b to the -3, and I'll show you why in a minute. But what you need to understand here is 8 and 9 are very similar. If you notice, the bigger exponent here was on the top, and my answer ended up on the top. For problem 9, my bigger exponent is on the bottom, and my answer ended on the bottom. Now, between 5 and 2, we did 5 minus 2 to get 3. And we did the same thing over here, 5 minus 2 to get 3, but because 5 was on the bottom, we left the 3 in the bottom. So that's where our rule comes from. Anytime you are dividing the same bases with exponents, you are really going to subtract your exponents. So this example is all numbers, so we can put it into the calculator. So 3 raised to the 4th divided by 3 raised to the 3rd, and we just get 3. Anytime you have numbers, you want to use that calculator because that's going to be the easiest, fastest way to get the right answer. So on this side, I have A and A. That's what I'm comparing. 8 to the 10 has more A's. There's 10 A's on the bottom and 3 A's on the top. So there are more A's on the bottom. Something that will be helpful for you is if you circle the biggest exponent, that's where your answer should end. Now again, we're subtracting our exponents. So 10 minus 3 is 7. It ends on the bottom because that's where I had more A's to start. Now, you could also write it like this, 3 top minus bottom. So we have 3 minus 10. We get a negative 7, and that negative is very unhappy. It does not like being on the top. So in order to make it positive and happy, we put it on the bottom. These two things mean the same thing. You don't have to know this rule yet with the negatives. We're going to deal with that on 11.3. But the A to the 7, you can always use the rule for today, at least. Wherever the bigger one is where your exponent is going to end up. So that's what I'm going to follow for the rest of this. On problem 10, 3 is bigger than 2 for your x's. For your y's, 5 is bigger than 2. So both my x's and my y's are going to end up on the top. For my x's, I have 3 minus 2, and I get an invisible 1. For my y's, I have 5 minus 2, and I get 3. Again, both of these end up on top. You don't have to write the exponent of a 1. You can if you want to. So you can write this as xy cubed or x1y3. Now, just like on the front with the big numbers, we treat big numbers the same. So 8 divided by 2 is 4. Now with the exponents, again, we subtract. There are 8 there are 8 m's on the bottom and 7 n's on the bottom. Both of those are bigger than the 5 and the 4 on the top. So when I subtract, they will end up on the bottom. 8 minus 5 is 3. 7 minus 4 is also 3. So the 4 stays on the top because that's where your bigger number was. M3, N3, end on the bottom because that's where your bigger exponent started. Now for problem 12, there's 2 different ways to do this. I'm going to show you one way on 12 and one way on 13, and you are free to do it whichever way you want. One thing you can do is treat everything, like pull it out and treat it all the same and do it all at once, which can get kind of confusing if you have a really long or complicated problem, but you can do it all at once and have less steps. So 6, 3, and 2 are my big numbers that I'm going to pull out. I only have the base of A. A has a 4 and a 2 on top. Because those are being multiplied, we would add them. And then because 5 halves is on the bottom, we would subtract because it's being divided. So for this, you really have to know, see, and understand your rules to know how to do this. If you don't get that, that's totally fine. I will show you what to do on 13. So 6 times 3 divided by 2, you can put into the calculator. 6 times 3 divided by 2, and we get 9. And then for your A's, you would literally type 4 plus 2 minus 5 halves. And you get 3.5, which is the same as 7 halves. And you would stop your problem there because there's nothing else you can do. Now again, that's the quick shortcut, but you have to know what's happening with the 4, the 2, and the 5 halves. You have to know whether you're adding or subtracting, and eventually timesing and stuff like that. If you don't see that, then take it and simplify the top first and then divide. So take it one step at a time. So we are going to simplify by multiplying, okay? Remember, like we talked about on the front, when we multiply, you multiply the big, add the small. So negative 3 times 4 is negative 12. M to the 3 plus invisible 1 is 4. M to the 2 plus invisible 1 is 3. And then we just rewrite. Okay, so that's step 1. I have simplified the top by multiplying this out and bringing it over here. I have done nothing with the bottom. Now the reason I simplify this out is because when you subtract, do you subtract 3 and 2 with these m's over here? Do you do it with this m over here? So I've simplified the top so that over here I can see exactly what I need to subtract. M to the 4 is bigger than m squared. If you notice, n to the 3 over 3, neither of these are bigger or smaller than the other one because they're the same exponent. Anytime you divide something by itself, it will cancel. So my ends are canceling for this problem. So with my numbers, negative 12 divided by 6 is negative 2. M to the 4 minus 2 is 2, and I'm done with that problem. Now again, if you can see it to where you can write it like problem 12 with the pluses and minuses, that's fine. Or simplify the top and then simplify the bottom. For problem 14, they are giving us the area in square feet. So our area formula is base times height. They are asking us to find the base. So we will need to do area divided by height to find the base. So we will take our area and divide it by the height to find the base. Now when we divide, we do exactly like we were just talking about. 36 divided by 9 is 4. X to the 8 minus 3 is 5, and it stays on the top because that's where I have more exponents. Y to the 7 minus 5 is 2, and it stays on the top because that's where I have more exponents. So to summarize, when you are multiplying, you really add the exponents. When you are dividing, you really subtract. The way I remember it is that multiplying and adding both increase. Subtracting and dividing both decrease. So whatever you're doing, if you see a multiplication symbol, you're really going to add the little numbers. If you see a division symbol, you're really going to subtract the little numbers.